Hello, my name is Andrea Presutti and I'm a PhD researcher. Today I'm going to talk to you about the 3R principles in animal research. The practice of animal testing in life sciences is a crucial step in the process of obtaining the approval of new medical devices, protocols and drugs by the controlling bodies like the Food and Drugs Administrations in the US and the European Medicines Agency in the European Union. While animal testing in bioengineering is less prevalent than in other research fields such as biology, it is still an inevitable step to go through during the experimental process. However, the ever-growing attention to animal welfare and to the ethical dilemma of their use in science, as well as the concerns related to the reproducibility of results when moving from animal to human testing, have made the so-called 3Rs principles approach paradigmatic in animal research. The 3Rs stand for replacement, reduction, and refinement. Replacement, simply put, has the goal of using alternative models in place of in vivo experiments while still retaining scientific relevance. Replacement can be full, when animals are completely excluded from the research activities, or partial in the case of animals being replaced with other animals which are believed to be incapable of experiencing pain or distress, such as invertebrates, nematode worms, or lower forms of vertebrates. Reduction aims at carefully planning the research activities in order to use the lowest possible number of animals, while at the same time maintaining statistical significance in the research. It also entails the maximization of the data that can be collected from one single animal experiment. Refinement, finally, aims at minimizing the suffering, pain, distress, and ultimately the number of sacrifices of animals when such type of research must be pursued. This can be achieved by not only improving the living conditions of the animals and adopting overall gentler handling approaches both before and during the experimental phases, but also by maximizing the use of non-invasive techniques such as imaging procedures like MRI or CT scanning. Replacement is the main long-term objective when adopting this approach. In this light, bioengineering has been playing a significant role in coming up with novel methodologies to circumvent animal research. In silico models are computer simulations that allow scientists to model pharmacological or physiological processes with a virtually unlimited number of input parameters. This, in conjunction to the in vitro research, gives researchers a significant vantage point in avoiding the in vivo testing while still obtaining significant reliable results. Another alternative to animal testing is represented by lab-on-chip or organ-on-a-chip devices which, by scaling down laboratory or physiological systems to a micro or nanoscale, allow scientists to integrate multiple functions and control an array of parameters all at once with much greater precision. This comes with a series of great advantages, such as lower fluid volumes, fewer waste or contained costs, counterbalanced by some drawbacks mainly related to the technology being both relatively young and extremely complex to implement from a physical point of view. In conclusion, possibilities are varied and it will be exciting to see how science will move forward and we with it.